So moving further, let's now discuss the ring topology. And there exist two type of ring topologies like single ring or dual ring, depending on whether the data is moving in a one direction, single direction, unidirection, or bidirection. Right. So between the neighboring nodes, how the data transfer happens. So based on that, it is defined as a single ring or dual ring. Friends, do notice this particular website. This entire content has been taken from dnstuff.com, and there is a very good article, as I mentioned, that what is a network topology. Very decent article. So basically, the ring topology. We'll see the diagram of the ring topology. This is the diagram of the ring topology. This how the ring topology looks like. So all the nodes, networking nodes. So networking nodes doesn't necessarily mean a only a PC or laptop or a computing device. It can be anything, like it can be a printer. Of course, there is a processor inside the printer also. It could be a even the storage space, the cloud. Anything can come there. So that's how you can see in this representative diagram. So there are many networking nodes, and this resembles like a ring. Therefore, it is called as ring topology. So here, each device is only connected to the only one directional, unidirectional kind of flow can happen. So this is a single ring, right? So the advantage of we'll see about the ring topology. So each device is connected to the one or either side when the data is transmitted. So here we use a term called as packet. So packet is nothing but the chunk of the data, because whenever data is transmitted over the network, the entire huge file is broken into small chunks, and those chunks are called as packets. We'll see the details whenever we discuss the OSI model. But this is how the packet kind of data transmission in packets takes place, and it travels along the circle because it's a ring kind of structure, and it can actually transmit in one direction, or it can transmit in both the directions, depending on whether it is a single ring or dual ring. So, and whenever they arrive at their destination, then the data is accepted by the node for which the data is meant to be received. uh, so if a large network is arranged in a ring topology, repeaters can be used to ensure packet arrives correctly without the data loss. The repeater is a device. It is not exactly amplifier. In electronics, when we talk about the amplifiers more often, but repeater is little different than the amplifiers. It is a regenerating kind of device. The logic 0 and logic 1 levels of the data at the lower level you can describe. So those are restored, because as the data transmits over a long distance, then there is every possibility that the logic 0 and logic 1 levels, they might get disturbed, or they might get affected. So in that case, there is a regeneration is required. So repeater is a device that just ensures the regeneration of the data. So here only one station on the network is permitted to send the data at a time. Okay, there is a protocol. There is a very popularly called as token ring protocol. So token ring protocol means the token is transmitted. So it is like a basket. You can use the analogy. It's like a basket, and this basket moves, and every node can put data in that basket with its address from where the data is originating, and the destination address where the data is supposed to be delivered. So the token moves across the network in a ring manner, and whenever the actually it reaches the destination, and whenever there is a matching of the address of the destination machine or destination node, then the data is delivered to the destination. So this kind of arrangement is used in case of ring topology. So at a time only one the actually the token moves, and then the data is getting accepted from the nodes, and then it is delivered to the nodes where it is supposed to be delivered. Now this particular arrangement, it greatly reduces the risk of packet collisions. Had it not been this kind of arrangement, there could have been lot of collisions, and then there is no full transmission and reception of the data. So here you get minimum errors because of this particular arrangement of transmission of the data. Uh, Another thing about the advantage of the single ring topology, they are cost effective, right? Because less cabling, inexpensive to install, very cost effective, and point to point connectivity of the nodes makes it very easy to identify the issues or misconfigurations of the network. So, from maintenance point of view, this particular arrangement is ideal. However, there are certain drawbacks of this ring topology. Though it is popular, it is vulnerable to failure because you know that there is a single cable which is running, and if there are some faults arises in the cable, then it is likely that the network will be down. And in this particular single ring, the flow of data happens only in unidirection between the nodes. So you can notice that one of the nodes, you can see the diagram and you can notice that if one of the nodes goes down, then the entire network will be down. So that is the main drawback of the single ring topology. So a particular node is down, then the entire network might be down, and it will affect the performance of the entire network. Even if the transmission line, the line which is actually carrying the data, if it is down, then also the entire network will be down. So now another issue of the ring topology, the scalability issue. Suppose if you want to add a device, then you have to take extra care to dismantle the network and put the additional device. Another thing is that addition of each of the device will add a certain delay in the data transmission, and this will affect the entire network delay. So the performance of the network, or the more technical language, it is called as throughput of the network. So throughput of the network will be affected if there are many more devices which are added in the ring, because every device will add its own delay, and this delay will be actually affecting the transmission between the source and receivers, source node and the receiver node. So therefore, addition of scalability issues are concerned, this network is not a very good choice, and delay affects the performance of the network. And one more thing, you can notice that whenever you want to add or remove a device, then the entire network has to be taken offline. It is not possible to do live, right? So live operation is not possible. You must put the network down. The entire network has to be put in offline mode, and then whatever you want to add a device or remove a device, those operations can be done, and again the network can be put in the online mode. So that is one more issue with this particular network. A better choice is dual ring topology, because in single ring topology, the transmission pattern is half duplex, but in case of dual ring topology, it can be full duplex. It is a full duplex, so that the data transmission in both the directions is possible simultaneously. This is the diagram of the dual ring topology. The same diagram, only thing is that the same diagram of single ring. The only addition you can see in this diagram is there exist two paths between the neighboring nodes. So in this way, there is a full duplex kind of pattern which gives you more bandwidth. So the primary advantage of this particular arrangement is that efficiency, the throughput is more because the data movement, the data transmission is possible in both the sides. Information can be sent clockwise or counterclockwise around the network. In case of the previous one, either clockwise or anti-clockwise is possible, but here it is possible uh, in both the directions simultaneously. The secondary ring is included in this particular ring topology, and this acts as a redundant layer. So, mind will, we have seen the drawback of the single ring topology. If the central cable fails, the entire network will be down. But this particular drawback can be eliminated in dual ring topology because there is additional cabling, and this cable can be used as a redundant backup for this particular network. So this overcomes a lot of advantages of the traditional ring topology. And one more thing is there is little extra security also, because if one ring fails within a node, the other ring can take over and it can sustain the network. The network can be functioning. So that is all about the dual ring topology. So these two topologies, the ring topology, single ring topology, you might have seen the drawbacks, and of course they are also there in the text. And in the dual ring topology also, you have seen the advantages. It's at the cost of little more cabling. Actually, you are getting more throughput, more bandwidth, more security, more reliability. All these are the advantages of the dual link topology. And now we'll move to the tree topology.